Right. This is Unit 2, Lesson 4, Dividing Rational Numbers. So in our essential question is what happens when you add, subtract, multiply, and divide rational numbers? In this lesson, we're going to learn about dividing positive and negative fractions using multiplicative inverses and dividing algebraic fractions. So to divide fractions, all of the properties of integers also apply to rational numbers. Two numbers whose product is 1 are called multiplicative inverses or reciprocals. So reciprocals is probably the term that you've heard most often, but they're also called multiplicative inverses. So the statement 1/4 times 4 equals 1 demonstrates this property too. So if I have 1/4 times 4, 4 times 1 is 4, 4 times 1 is 4, 4 divided by 4 is 1. Okay? So our key concept, inverse property of multiplication. So the opposite of multiplication we know is division. The product of a number and its multiplicative inverse or reciprocal is 1. For every number a over b, where b can't be 0 and a can't be 0, there is exactly one number, b over a, such that a over b times b over a equals 1. For example, 2/3 times 3/2 equals 1. So basically, the numerator and the denominator of the fraction get switched. Find the multiplicative inverse of each number. So I have 7/16, so I flip it. I have its multiplicative inverse or reciprocal, and it becomes 16 over 7 equals 1. So the multiplicative inverse or reciprocal of 7/16 is 16/7. For b, -6 1/3, this one's a little bit trickier because you have to change the mixed number into an improper fraction. When you do that, remember you multiply 3, my denominator, times my whole number, and I add my numerator. Ignore the negative sign and just add it in at the end. So 6 times 3 is 18, plus 1 is 19, over 3, my denominator stays the same, and then I just add that negative sign out front. I have to remember that negative sign when I do my multiplicative inverse or reciprocal, because a negative times a negative is a positive. So -19 thirds and 3 19ths equal 1. Okay, so the multiplicative inverse or reciprocal of -6 1/3 is -3 19ths. All right, so let's do these problems to find out. I have -7/9. Okay, so -7/9, my reciprocal is going to be -9/7. Remember, I just flip my numerator and my denominator. I keep the same sign. For b, I have 2 1/12. I need to change this mixed number into an improper fraction. So that means 12 times 2 is 24, plus 1 is 25. So I have 25 over 12. And then I need to flip this. So this becomes 12 over 25. So key concept, dividing fractions. To divide by a fraction, I multiply by its multiplicative inverse. Sometimes this is also called keep, change, flip. I keep the first number the same. I change my sign from division to multiplication, and I flip my second number, whether it's a whole number or a fraction. Okay? It's also called multiplying by the multiplicative inverse or multiplying by the reciprocal. So for example, 4/9 divided by 3/5 becomes 4/9. I keep my first, I change my division to a multiplication sign, and then I flip my second fraction. 3/5 becomes 5/3. So in letters, I have a over b divided by c over d equals a over b times d over c, where b and c and d can't be equal to 0. Okay. To demonstrate this concept, consider 4/9 divided by 3/5 and a over b divided by 6 over d. So 4/9 divided by 3/5 becomes 4/9 times 5/3 over 3/5 times 5/3. Okay, so I multiplied both my numerator and my denominator by the same number. Okay, and I'm multiplying by its multiplicative inverse, so it becomes 1 on the bottom. So I have 4/9 times 5/3 over 1, which becomes 4/9 times 5/3. Okay, it's just proving that this actually works. A over b divided by c over d equals a over b times d over c over d times d over c. I multiplied, that becomes 1, that's its multiplicative inverse. A over b times d over c is my final answer. All right, so let's try it. Find each quotient, write in simplest form. So I have 1/9 divided by 5/12. So I keep, change, flip. Okay, 1/9 times 12/5. I can see that 9 and 12 will cross simplify. So 9 becomes 3 and 12 becomes 4. So I have 1 times 4, 3 times 5, which is 4/15. I can't reduce any further. Okay. Then I have 3/7 divided by 8. Well, 8 can be written as a fraction as 8 over 1. Okay. Any whole number can be written over 1 and make it a fraction. So I have 3/7 divided by 8 over 1. That becomes 3/7 times 1/8. Okay. There's nothing that I can cross simplify, so I just multiply straight across. 3 times 1 is 3. 7 times 8 is 56. All right, let's try it. So for 2a, I have 1/3 divided by 7/15. So this becomes 1/3. I change my division to multiplication, and then I flip my second number. So 7/15 becomes 15/7. Okay. I can cross simplify, so 3 and 15 cancel. So I have 1 here and 5 here. So that means I have 5 over 7. Okay. For B, I have 5/8. Keep my first. Change my division to a multiplication sign, and I flip my second fraction. Remember, keep the negative sign the same. So -3/4 becomes -4/3. Okay. Again, I can cross simplify 8 and 4. 4 becomes 2. 8 becomes 4. So when I multiply, 5 times 2 is 10 over 4 times 3 is 12. I can still simplify. Okay, I can divide both of these by 2. So this equals 5 over 6. I could have also recognized here that 4 could have become 1 and 8 could have become 2, and I would have gotten the same answer. Okay, for C, I have 3/4 divided by 11. So 3/4, keep my first, change my division to multiplication, and 11 I can rewrite as 11 over 1. So this becomes 1 over 11. There's nothing that I can simplify. So 3 times 1 is 3. 4 times 11 is 44. So that one becomes 3 over 44. Okay. For 2D, I have -6/7 divided by 12. So -6/7. Keep my first the same. Change my division sign to a multiplication sign, and I flip my second number. Remember, 12 becomes 12 over 1. So I have 1/12. We can simplify some stuff. 6 and 12, I can divide both by 6. So I have 1 here and 2 here. So 1 times 1 is 1. My negative sign just kind of hangs out. This one's also negative. 7 times 2 is 14. So I get -1/14. All right, for example 3, find -4 and 2/3 divided by 3 and 1/9. Okay, so I'm going to do the exact same thing. The first thing that I want to do is I have mixed numbers. I want to change them to improper fractions. So -4 and 2/3, 3 times 4 is 12, plus 2 is 14. Leave the negative the same. 3 and 1/9 becomes 9 times 3 or 27, plus 1 is 28 over 9. Now I keep, change, flip, or multiply by the reciprocal, which becomes -14 over 3 times 9 over 28. I can cross simplify. 3 and 9 cross simplify to become 1 and 3. And 14 and 28 cross simplify and become 1 and 2. And multiply straight across. -1 times 3 gives me -3. And 1 times 2 gives me 2, which I can change back into a mixed number, which gives me -1.5. You can also leave it as -3/2. It's still the same thing. Let's try it out. I have 6 and 3/8 divided by -4 and 1/4. So I want to change these to improper fractions. So 8 times 6 is 48. 48 plus 3 gives me 51 over 8. Okay. 4, -4 and 1/4. 4 times 4 is 16, plus 1 is 17. So this is divided by 17 over 4. Remember to keep the negative sign. Okay. So I'm going to keep, change, flip. Okay. So 4 and 8 simplify. They become 1 and 2. 51 and 17 also simplify. So 17 becomes 1, 51 becomes 3. Okay, and then I'm left with 3 times -1, which gives me -3, and 2 times 1 gives me 2. So I have -3/2, which also equals -1 and 1/2. Okay. For B, I have -6 and 4/5 divided by -2 and 2/5. So I change each one to an improper fraction. So 5 times 6 is 30, plus 4 is 34. So 34/5, and it's negative. Divided by 5 times 2 is 10, plus 2 is 12. So -12/5. Okay, so this becomes -34, keep over 5. Change my division to multiplication, flip my second number. Okay, so 5 simplifies. This becomes 1 and 1. And 34 and 12 can simplify. So 34 divided by 2 is 17. So I have 17, and then 12 divided by 2 is 6. Okay, now I'm going to go ahead and multiply. So I have 17, -17 times -1, which gives me 17. And 1 times 6, which gives me 6. So I get 17, 6, or 6 goes into 17 twice with 5 left over. So 2 and 5/6. All right, division can be used to find the number of equal sized groups in a real world situation. So Tessa feeds her dog Roscoe 3 3/4 cups of dog food per day. If she buys a bag of food that contains 165 cups, how many days will the bag of food last? To find how many days, I divide 165, the total number of cups, divided by how much she feeds Roscoe every day, 3 3/4. So 165, I rewrite as a fraction, so 165/1. And 3 3/4, I change from a mixed number into an improper fraction. So 4 times 3 is 12, 12 plus 3 is 15. So 165/1 divided by 15/4. I keep my first one the same. I change my division sign to a multiplication sign, and I flip my second fraction. So I have 165/1 times 4/15. I can cross simplify. 15 goes into 165 11 times. So I have 11 times 4 and 1 times 1, which gives me 44. So the bag of dog food will last 44 days. You can always double check. Tessa feeds her dog about 4 cups of food for a little longer than 40 days. So the number of cups the bag contains should be about 4 times 40, or 160 cups. So the answer seems really reasonable. Let's try it. A box of cereal contains 15 3/5 ounces. If one bowl holds 2 2/5 ounces of cereal, how many bowls of cereal are in one box? So a box of cereal contains 15 3/5 ounces. That's the total amount that it contains. And one bowl holds 2 2/5. So I'm going to divide 15 3/5 divided by 2 2/5. But I want to change 15 3/5 from a mixed number into an improper fraction. So 15 times 5 is 75, plus 3 is 78. So I get 78/5 divided by 5 times 2 is 10, plus 2 is 12. So divided by 12/5. I keep my first, change my division into a multiplication, and I flip my second fraction. Okay, I know that 5 and 5 can simplify to 1 and 1. 78 divided by 2 is 39. 12 divided by 2 is 6. And then I can divide both of these by 3. So 39 divided by 3 is 13. And 6 divided by 3 is 2. Okay, so when I multiply, 13 times 1 gives me 13. And then 1 times 2 gives me 2. So I have 13 over 2, which will simplify to 6 and 1/2. So there's about 6.5 bowls of cereal in one box. So when I divide algebraic expressions, you can divide algebraic fractions in the same way that you divide numerical fractions. So example 5, find 5 over 3ab divided by 15 over abc. Write the quotient in simplest form. So basically, I'm going to do the exact same thing that I just did with normal fractions, except now I have letters. Okay? So I have 5 over 3ab divided by 15 over abc. I keep my first, change my division sign to a multiplication sign, and then I flip my second number. So I have 5 over 3ab. Division becomes multiplication, and then ABC over 15. I can see that the A and the B cancel each other out, so I'm left with C up top, and 5 and 15 cancel each other out. So 5 becomes 1 and 15 becomes 3. So I'm left with C over 3 times 3, or 9. All right, so let's try it. I have 5AB over 6 divided by 10B over 7. So I keep my first, so 5AB over 6, change my division sign to multiplication, and I flip my second number, so my reciprocal. Okay, now I'm going to cross out what's the same. So I have a B up top here and a B here. 10 can simplify to 2. 5 simplifies to 1. So I have 1A times 7 over 6 times 2. So 1A times 7 gives me 7A. 6 times 2 is 12. That's as simplified as I can go. 7/12 doesn't simplify any further, and I can't do anything else with the B because there's nothing that I can cancel it out with. Let's try B. MN over 4 divided by M over 8. Remember, I keep my first one the same. I change my division to a multiplication sign, and I flip my second number. Remember, it's also called multiplying by the reciprocal or the multiplicative inverse. Okay, from here I can see that M cancels. 4 and 8 also simplify, so this becomes 1 and 2. Now I just multiply straight across. I have N and 2 left, so that becomes 2N and 1 and nothing else, so that's 1. So this becomes 2N over 1, or just 2N. And that is the end of Unit 2, Lesson 4.